Have you ever wondered what really happens inside your engine when you fill your fuel tank with E20 petrol? Although E20 looks almost identical to conventional gasoline, its chemical composition changes the way your engine burns fuel, manages combustion, controls emissions, and even adjusts engine performance. Behind every combustion cycle, modern engine control systems continuously make intelligent decisions to ensure efficient and reliable operation. Welcome to Automotive TechX. In this video, we'll explore the engineering behind E20 fuel and understand how modern gasoline engines are designed to operate with ethanol blended petrol. E20 fuel is a blend containing 20% ethanol and 80% gasoline. Ethanol is an alcohol-based renewable fuel primarily produced from agricultural crops such as sugarcane, corn, and other biomass. Unlike conventional gasoline, ethanol molecules contain oxygen within their chemical structure. This additional oxygen promotes cleaner combustion by allowing fuel to burn more completely inside the combustion chamber. Once E20 enters the fuel tank, the electric fuel pump delivers the fuel through the fuel lines toward the engine. Before reaching the injectors, it passes through the fuel filter to remove contaminants that could affect injector performance. The fuel then enters the fuel rail, where pressure is carefully maintained to ensure precise fuel delivery during every combustion cycle. Each fuel injector is electronically controlled by the engine control unit, commonly known as the ECU. Based on information received from multiple sensors, the ECU determines the exact amount of fuel to inject and the precise timing required for efficient combustion. The mass airflow sensor measures the amount of incoming air, while the manifold absolute pressure sensor helps estimate engine load. The intake air temperature sensor measures air temperature, and the engine coolant temperature sensor indicates engine warm-up conditions. Together, these inputs allow the ECU to calculate the ideal air-fuel mixture for every driving condition. Because ethanol contains less energy per liter than gasoline, E20 generally requires a slightly greater quantity of fuel to produce the same engine power. To compensate, the ECU increases injector pulse width, ensuring that the correct amount of fuel enters the cylinders. Oxygen sensors installed in the exhaust system continuously monitor combustion efficiency, allowing the ECU to make real-time fuel corrections through closed-loop fuel control. Another important difference is ethanol's higher octane rating. Higher octane fuel has greater resistance to engine knocking, allowing combustion to occur more smoothly under higher compression conditions. This helps improve combustion stability and can contribute to better engine performance, especially in engines specifically calibrated for ethanol-blended fuels. During combustion, the air-fuel mixture is compressed by the piston before the spark plug initiates ignition. The burning mixture rapidly expands, pushing the piston downward and converting chemical energy into useful mechanical power. Since ethanol contains oxygen within its molecular structure, combustion is generally cleaner, resulting in reduced carbon monoxide and hydrocarbon emissions compared to conventional gasoline. However, E20 fuel also presents engineering challenges. Ethanol readily absorbs moisture from the atmosphere, making proper fuel storage important. It also has solvent properties that may affect older rubber seals, hoses, and certain fuel system components not specifically designed for ethanol compatibility. Modern vehicles approved for E20 use upgraded materials that resist ethanol-related corrosion and degradation. The ECU continuously adapts ignition timing, fuel delivery, and emission control strategies based on sensor feedback. Advanced engine management systems can quickly detect combustion changes caused by ethanol content and automatically optimize engine operation without requiring driver intervention. This intelligent control ensures smooth performance, reliable starting, and compliance with emission regulations. From an environmental perspective, E20 supports reduced dependence on fossil fuels while increasing the use of renewable agricultural resources. Although fuel economy may decrease slightly because ethanol contains lower energy density, the overall reduction in harmful exhaust emissions and the use of renewable fuel sources contribute to improved environmental sustainability. E20 fuel is much more than a simple blend of gasoline and ethanol. It represents the integration of fuel chemistry, electronic engine management, advanced sensors, precision fuel injection, combustion engineering, and emission control technologies working together to deliver cleaner, safer, and more efficient transportation. Thank you for watching Automotive TechX. If you enjoy learning the engineering behind modern vehicles, subscribe to the channel and join us for more in-depth technical explanations covering automotive systems, diagnostics, ECU technology, electric vehicles, and the innovations shaping the future of mobility.